So how the model can be structured for the air taxi, you can see on this particular slide, and this is one of the examples how we did it before with our clients. So I'm showing here several utility functions which were included in one of the models, just to give an idea of some specifics how to construct it. You can see here the utilities for private transport, VTOL, and public transport. And one important aspect in that particular study was implementation of the additional component into private transport utility function. So as you can see, there is a constant, mode-specific constant component, which is quite traditional for mode choice modeling, the travel time, with consideration of the value of time, and the last component, which is TTV. This is a reliability of the travel time by car, because this is quite a dynamic parameter and it may vary from day to day. An estimation of this value as part of the study gave an additional benefit, because the client was able to realize that actually efficiency of the air taxi will vary in different time periods, and it will vary from day to day. Other than that, the setup of the mode choice model is quite traditional. We've done it with the classical logic model for estimation of the demand. And the important aspect of the air taxi study is to calculate actually the optimal locations for the air taxi. The reason for having this optimization task as part of the air taxi forecasting study is in the fact that due to the access and egress mode being present in the picture, the location of the hub really plays a big role and influences the demand of the system very much. That is why optimization of the locations is very important. And I'm presenting here a quick overview of the optimization algorithm that was utilized in the study. So effectively, we've done calculation of the scheme matrices, travel times, and costs. We did the calculation of the mode choice, and that was for all possible combinations of the hub locations in the study area. And then we've applied the optimization function to maximize the number of passengers. So effectively, this is an iterative process that requires quite a significant number of iterations to come up with the optimal demand. How the procedure sequence in the model looked like. We had 3 sections in that particular study for the procedure sequence. Initially, we performed the optimization of the hub locations by calculating the schemes, estimating optimal locations based on a custom script which incorporated the target function. Then we incorporated the air taxi mode into the supply and demand models and performed the calculation of the demand loop, which covers the calculation of schemes, calculation of air taxi schemes with the multimodal assignment, the mode choice, calculation of the demand on path legs for air taxi trips. So that's the demand for access mode, the air taxi itself, and the egress mode. We performed the assignment of PRT and PUT modes and looped this set of procedures until the convergence. Finally, we've done the assignment for private and public transport modes, calculated schemes for auxiliary air taxi PRT mode, provided demand matrix time series for air taxi. And the final step was to assign air taxi demand using the shared mobility module to get service parameters. So effectively, this is a dynamic assignment that allows to evaluate the fleet sizes to serve the forecasted demand. The KPIs that were produced are presented on this slide, and you can see that there is quite a lot of parameters that can be derived out of this approach. Supply-wise, you can obtain the information on the number of vehicles in service per hour, number of service trips, daily operating costs, energy consumption, and some others. Demand-wise, you can assess the number of boardings, the mode split, the shifts from other modes. You can assess the travel time KPIs and obtain the information about the revenues as well. So that's the framework that I wanted to present related to air taxi. And now I'd like to shift to the Hyperloop. And here, first we need to understand what is the Hyperloop system actually. It's not a secret that the idea came from US, and it's a combination of two well-known technologies, the pneumatic pipes and the maglev technology. One which allows to achieve very high speeds of transportation. There is an uncertainty until now across all the potential vendors of the Hyperloop, what is the best use case or what is the best application for such a system. So there are quite a lot of studies coming up with relation to Hyperloop, and we've been part of several of them where the questions are raised how to actually position the system. Is it a mode which can become a new mode in urban environment? Is it a regional long distance commuter or a countrywide metro? Or maybe the best application for the Hyperloop is on the freight side rather than on passengers, because there can be identified some potential in urgent cargo transportation or same-day cargo delivery, or it may become a long-distance on-demand system. Last year, we've been working on a Hyperloop project in Middle East, which is a nationwide project where we were assessing the potential of the system from various aspects. And before actually going into the modeling aspects of it, I'd like to give you some idea of how the Hyperloop can fit into the nature of the mobility systems at the regional, national, and urban level. This is one of the analysis that we did based on the travel costs, travel distance, and travel time, comparing Hyperloop with traditional private cars. And what we found out is that effectively the commuting distances nowadays may reach all the way up to 120 kilometers or even more in certain countries by car. However, if we introduce Hyperloop as a system around the urban area, we may not only extend this distance, and we can almost double these distances, but we can also save on the costs of transportation in case if Hyperloop will achieve significant level of maturity of technology and will allow to deliver competitive costs to passengers. So in this particular case, it means that there is a own niche for this particular system that can be discussed at the regional level or on the level of metropolitan areas that have challenges with land use development and with current congestion. And this was quite an interesting discussion during the project, even though based on quite a simple comparison. So now diving a bit deeper into the methodology for Hyperloop modeling, I would say that effectively the method is very similar to what I've described with the air taxi. Hyperloop will require access egress modes as well, not due to the same issue of very dense urban environments, but due to the fact that this is an intercity mode, which typically have limited number of stops within urban environment, and the final destination may be quite far away from the potential location of the Hyperloop hub. So it falls into the same concept of multimodality and will require quite a similar setup during modeling. You can see in this flow chart that the structure of the mode choice model will look very similar to air taxi, how it was described. It's also very important to define a set of parameters for the Hyperloop system itself, as well as for the air taxi. It is required to work out a quite detailed supply model. And there are some aspects that play a big role in forecasting of Hyperloop. I'm going to mention them a bit earlier. Assessment of the existing Hyperloop studies is very important as well, and there are quite a lot of them delivered already, available even on the internet, which show quite interesting conclusions from different perspectives. Hyperloop can be modeled based on the existing national or regional transportation models. It requires stated preference survey as well. However, in the studies that we did, we used benchmarking techniques. We didn't have a chance to perform an SP survey for the Hyperloop. However, benchmarking worked quite well. And I will show you later on how we, what kind of tweaks we applied to the model to be able to produce reasonable forecast numbers. And yeah, that's actually the content of the mode choice model for the Hyperloop. The only potential difference comparing to the air taxi is that modeling of Hyperloop with the shared mobility modules or with the demand dynamic assignments doesn't make too much sense because of the travel times of the competing modes. Usually they are way longer, and here some simplification can be used. So that's potentially the key difference in the modeling approaches. And I've been talking about multimodal assignment that needs to be in place for both modes of transport in case if we would like to go for such a study. And that's why I'd like to show you an example implementation of the multimodal assignment and how the procedure sequence might look like in PTV Zoom to set it up. You can see here the parameters for the scheme matrices of the path sequences. As you remember on the air taxi slides, I was showing that there should be an access mode, the main mode itself, and the egress mode. That's why we can see here that in the multimodal assignment, we would need to set up the potential access mode that can be not only private car, you can include several of them and define schemes for each access mode. In this case, the calculation of the mode choice will be based on weighted average of access modes and weighted average of egress modes. And the procedure sequence is as follows. You would need to define the multimodal supply mask, which is effectively a 0-1 matrix, which defines possible connections for the new mode of transport. You'll need to calculate the shortest multimodal paths per OD pair with the procedure multimodal assignment. The result of it will be a set of path sequences in PTV Visum, which can be used to calculate the multimodal schemes. And those multimodal schemes will contain all the information about the travel times, transfers, access times, origin wait times, and so on. In this particular example, I've defined 7 scheme matrices. The next procedures will combine these schemes into total multimodal travel time and costs. And at the next step, in this example, I'm showing the creation of the utility function, which utilizes the multimodal total travel times and cost matrices. Next step is to perform the mode choice as if you are doing it in any other traditional model. The only difference is having the new mode of transport included as a main mode in here. And the next step would be to rerun the multimodal assignment, but in this case, instead of using a supply mask, we will use the actual results of the mode choice and the actual modal matrix of the Hyperloop in this example to regenerate the path sequences and apply the potential demand on the path sequences. And the last step is to disaggregate the origin destination matrix from the multimodal assignment to leg matrices for the new mode and relevant feeder modes. After that, you can perform the traditional assignment to observe the actual volumes on the network. And lastly, I'd like to mention the way how in this particular example it is possible to calculate the to come up with the elastic model or Hyperloop given the absence of the SP data, for example, or stated preference which is not possible to, let's say, transfer to this particular mode. What we've been using in a couple of projects is a so-called user saving calculation, which reweighted the fares for the new mode. So effectively, we were not taking a fare as an input from a client for the Hyperloop system, but we were calculating this fare on the fly based on the closest benchmark mode. And on top of the fare of the closest benchmark mode, we were adding an extra charge, which was calculated based on the saved time by the user. So it's so-called 100% user saving. If we try to convert it into a simple example with numbers, we can say that if a person is going to save 1 hour of time because of taking a Hyperloop trip instead of a flight, then the fare of Hyperloop will be an airfare plus a charge of 30 minutes multiplied by the value of time of that particular person group. This allows to produce a fare matrix which falls into a reasonable range of fares that is higher than closest benchmark mode, however, not overcharged, and users may see a benefit. At the level of pre-feasibility studies, this is quite a viable approach that allows as well to assess what is the reasonable range of fares to allow people to start considering Hyperloop, in this case, as a competing mode of transportation. And to conclude my presentation, I'd like to say that for actually both of the modes that I discussed today, the air taxi and the Hyperloop, based on the studies that we've done or we've seen delivered by others, there are quite a lot of new domains that can be opened with implementation of these modes, even though we may think that they will be just in competition with existing mobility systems. One example I showed to you today, for example, a commute of 300 kilometers, which will not be longer than 1 hour with Hyperloop, that's something that may revolutionize the land use development model of a country and allow to pull out residential areas from metropolitan areas and optimize the way how we think about congestion. That's, I think, it. Now we can go into maybe some Q&A.
Thank you, Boleslav. Yes. Getting some echo here. We appreciate everyone. Feel free to continue to type in your questions in the question box. I have a couple so far, but feel free to continue to add your questions into the questions box, and we can proceed. So the first one, the timing of the question was during the air taxi portion, but it may apply to both. The question is, are the route choices based on the vehicular paths?
That's a good question, actually. Not really. In the studies that we were doing, there was an assumption about the direct line transportation with an additional assumption of average transportation speed. And this is something that needs to be taken into consideration along with the consultant who is dealing with the airspace. Because the study was performed by the planning agency, strategic planning agency, who is not very well connected with the aviation sector. And this is a potential shortfall for such studies, because there is no visibility on what's going on in the airspace, and there are no sufficient assumptions about that, which may cause not very accurate calculation of the travel times. So for the air taxi, that's something that needs to be taken into account. Hyperloop is straightforward in terms of this because it's just a layout similar to any other land transportation system.
Okay, thank you very much. Another question regarding the air taxi is it just getting more information on, were you looking in terms of the use case of the air taxi, looking in the geographical space, specifically in like high density locations, or that as well as potentially these maybe trips that would be similar to this extended commute like you were describing from a Hyperloop perspective?
Yeah, thank you for the question. I would say for air taxi, there were two main use cases in assessment. One of them is high density residential area to high density CBD. And another one is last mile from the airports. So this is like an alternative to Aero Express and rail connection between the airport and the CBD.
Okay, great. Question on what is the time and price for 1,000 kilometers, and what would be the speed? This is related to Hyperloop.
This depends on the Hyperloop system definition. In the initial paper released by Elon Musk, he was mentioning that Hyperloop can reach 2,000 plus kilometers per hour. However, this is more of a theoretical number. When we go down to the assessment of the technology, I would say we will land to somewhat between 700 to 1,200 as a reasonable speed, depending on the set of assumptions, on the pod types, and so on and so forth. So you can derive the travel time out of these assumptions. So that's going to be about an hour, plus minus. In terms of the price, as I said, we've not considered the assumptions of the client about the pricing, because there was a very hot discussion about the maturity of the technology, when Hyperloop can reach to the state when we can apply it to demand segments with low or medium income, because obviously today it won't be possible. That's why benchmarking versus air travel at the national level was used, and that's why we applied the user saving technique calculation. So effectively the price is air plus the time saving, charged on top, half of the time saving charged on top. And here one more important aspect is that I didn't mention, is that for the Hyperloop, results will be highly dependent on the way how you will locate the hubs of the Hyperloop. Because in case if the hub is located outside of the city, somewhere next to the airport, then the operational speed of Hyperloop doesn't allow to compete with air, realistically. And it becomes applicable only for distances like shorter than 500 kilometers. More than that, it's not. It is a bit challenging. However, if there is a potential to connect it to CBDs or go inside the city at least, then there is quite a good competition on the distances all the way up to 2,000.
Okay, great. The next question is your thoughts on when either or both air taxi and Hyperloop might have a considerable share within the future. Like, you know, is there any projections on timelines of when to actually reality see these in action?
Look, I think this is really technology dependent, because if we assume that the level of development of these technologies today is 100% and we can just go and build it, then both systems will organically go into the transportation systems, relevant transportation systems. Air taxi will become part of urban environment, and Hyperloop will become part of national and regional networks immediately. And from what we've seen out of the analysis, air taxi is like a competing mode for distances like longer than 30 minutes by typical mode of transport. Hyperloop has its own niche as well, and that is, I already mentioned, so that there is a potential for an extension of the commute. From one perspective, this is a way for cities to reimagine their land use, but from another perspective, it can be a shortfall as well, because in case if we connect Hyperloop to an existing city which is 300 kilometers away, we may get an extra attraction from there. So I think the shares can be quite high. However, the level of maturity of the technology will not allow us to observe any numbers that are going higher than average model accuracy in the next 5 years. So that's not going to be significant.
Okay, thank you. The next question has to do with the fuel type, relates to the fuel type of the air taxi. So the question says, are air taxis involved in the study all electric vehicles? And if so, was the cost considered in the study for building charging stations? And how long would the air taxis fully charge, and what is their range?
Yeah, they were electric, fully electric. Charging stations, yes, they were considered. Several strategies were tested: opportunity charging, overnight charging, and relevant cost calculations were performed as well. So, but this was, I would say, a separate scenario because because of the nature of these calculations. Having a vehicle which is fully electric gives us a need to assess what type of a battery we should put on board, how long we would like to keep the vehicle in the air without recharge, and these strategies, they need to be tested separately. So it was more of a side exercise rather than the main course of the project.
Okay, sounds good. And some more questions related to the specifications or characteristics of the Hyperloop. If you can answer these, or even the air taxi. I'm going to read it out here. It has to do with let's see, do passengers need to be seated at all times with seat belts? Does the Hyperloop run on the surface, underground, or above the ground? Any ideas on costs per 1,000 kilometers of network? And then how many people can travel in an air taxi or on a Hyperloop in each vessel?
Yeah, this is like a very good question. And during the project, we've worked on the definition of the Hyperloop system for quite a while. What I can say that this is very region specific and the purpose specific as well. Because if you are considering only Hyperloop as a passenger system or Hyperloop as a passenger plus freight or only freight, you will end up with a completely different construction costs and completely different operational costs. The positioning of the system, due to the fact that it's just a tube, you can put it above ground, on the ground, or underground. Even there are examples available on the internet where there are concepts of putting the Hyperloop underwater to cross gulfs of seas, or to put, let's say, port terminals offshore and allow delivery of the containers from the deep sea right into the mainland. So there are various ideas here. In terms of construction costs, I would say that generally trend would be very similar to road construction. So tunneling is going to double or triple the price. So this is quite typical. And in terms of the operational definition of the system, there are also different configurations, but it seems to be most reasonable to define a Hyperloop pod to be somewhat around the medium-sized bus capacity with dynamic parameters of the system similar to the trams because of the comfort of the passengers. So there will be a limitation on the acceleration and deceleration. And if you will start to study the start profiles of the speed profiles of the Hyperloop, you will realize that the acceleration and deceleration time plays a big role in the travel time of Hyperloop. And it may cause the diversion of the demand on certain distances from Hyperloop back to the original modes if you will change the assumptions on acceleration and deceleration.
All right, very interesting and good points. Thank you. The next question has to do with the air taxi. what altitude will the air taxi fly, and how is the planning going to? Sorry, let's see if I can read here. How is the planning going around avoiding other hazards such as towers, drones, above ground electric lines, etc.?
There are, of course, some studies related to that, but from what I know, in different regions, this is completely different. European studies are mainly talking about similar operational concepts with commercial aviation, somewhat limited number of routes above the cities, and like more of trying to drag the air taxi into the same concept of regulation of commercial aviation. But if we look into other studies in Middle East, there is no such a perception, and there are some completely new ideas. If we try to think about high-rise buildings, like very high towers in a very dense areas, there are even examples of studies where it is allowed to fly below the highest buildings. So it really depends. Currently, not too many vehicles are available on the market, and actually we need to see the vehicles first to be able to regulate them somehow. So this is more of a philosophical, I think, question at this point of time.
For sure. Great. Well, I have a couple thoughts that come to mind of my own, and maybe you covered part of it. Apologize. But one thought with the air taxi and thinking, you know, always thinking of new modes, but then how are they similar, or how might they struggle with similar things that existing modes have struggled with? And so, and then when you're talking about high density residential to high density CBD or et cetera as one of the potential pairing, my question is what is the thought on utilization rates, if you will, or like, you know, is there going to be deadheading in the traditional sense of like buses driving around in one direction full, the other direction empty, in terms of like where are these air taxis going to be stationed? Like, are they going to be dwelling for long periods of time after drop-offs? What's kind of the thought process and how these systems would operate in terms of maybe those components, and how do you model them?
Yeah, that's a very good question. And actually, this is where the segmentation of the demand in the model plays a very big role, because there might be different use cases to apply the air taxi. One of them can be the VVIP transportation from the airports to, I don't know, luxury hotels, or to convention centers, like helicopter type of a service for VVIPs. In that case, this is a very low occupancy. There are a lot of empty trips in need of repositioning them, and utilization of the fleet is not going to be very high. In case if we can track the price of the ticket quite low, then we may attract other demand, which is more regular, which will allow us to achieve higher occupancies. At the same time, it can be more of a transformation into a touristic mode, which connects specific tourist sites, and it is marketed in the city, not for, let's say, daily transportation, but more for transportation of visitors around the city. In that kind of cases, you may achieve higher utilizations, and you would not need to go too low on the price. So it really depends on the concept of what's the idea of implementation of the air taxi within a city. As we've discussed before, we still have another 5 or maybe even more years until the clear understanding of what's available on the market, and the set of vehicle types will be there, so that cities will be able to choose out of established set of OEMs. Then we will see how it works out. But yeah, we've seen several examples in our studies, and some of them were focusing on commuters, some of them on visitors, some of them ended up with the conclusion that no, it's going to be only a origin to origin. It's like a circular loop for tourists, and that's it, just as a fancy thing for the city.
Okay, excellent. Good to hear. Last question, I think, given the time, is can you elaborate on how to do an initial optimization of hub location? And then in parentheses, script based.
Yeah, look, that's actually an automation. As far as I mentioned, that you would need to go through a set of combinations of the hub locations. You would need to rerun the scheme calculations, and you would need to recalculate the mode choice for that. So there will be quite a lot of iterations. So script-based means that there is an automation of the runs, validation of the target function, and model rerun until we reach the optimization criteria.
All right, excellent. I think given the time, I'm going to go ahead and close off. If there's any questions that are still coming in that we haven't answered, we'll get to those via email in the near future. And let's see, Jamie, are you closing us out?
What was that?
Sorry, were you going to close us out with anything else?
No, I think that we're good to go here. If you have any further questions, you can reach us at marketing.us@ptvgroup.com. Thank you very much, everybody, for attending.
Thank you very much.